Okay, so we'll start. I don't know why everyone else joins late. Yeah, we can start. Okay, before actually starting these things, I would just like to give you a brief about the Spark. Why I'm not able to hide it. Okay, this is the yes, that's fine. Just a quick one, huh? See, understand first of all, Spark is it's not so easy to admin. Okay, you can say it like this. When we run Spark engines on normal Hadoop clusters or on-premise cluster or any cluster or any space where we have to manage the Spark, okay, in those cases, this Spark is something else, okay. But for us, we are learning the cloud technologies. Here, this Spark engines are we are running on top of Glue. Glue, or what it does, it launches Spark's executor, which has some memory. It launches workers, okay, and that help you run the Spark code. And due to this Glue nature, or as it is a managed service, we do not have any options to set up the Spark properties. Okay, we cannot go ahead and set up any Spark properties here on the Glue. On the other hand, when we are on the on-premise or any Spark engines where we could set these things, okay, for example EMR also, where we can set up the Spark things, that is a different Spark. Not in the sense of its use cases, not in the sense of its syntaxes, just that your interviews questions will change. That's what I'm trying to say. When you say in interviews that you know Spark on an admin level also, that is a completely different world, okay. But when we say Spark is a developer mindset, that is a different world. That's all I'm trying to say. And on clouds, on Glue specifically, we cannot do admin side of work because it's a managed by AWS. It is not managed by its customers, okay. So first of all, whenever you see some questions about Spark configurations, Spark's broadcast variables, or parallelism, or some other properties, those are mostly known by the developers who are actually working on the on-prem system, okay, or by the admins mostly. We do not have those kind of features here. Now Spark is built by a firm known as Apache, and they have basically built a engine which can help you do data transformations using SQL programming language, data transformations or data processing using Python and Scala, okay, over the Spark engines. You can have streaming engines, that is to solve your live data. Then we also have machine learning libraries and graph computation power also available. So we can say multiple features are available, and we are going to focus on the Spark SQL, that is a batch processing API of the actually Spark. Okay, here we are going to see the data frames and Spark SQL. Down here, I have some platforms where you can run the Spark, and this is coming from the on-premise side. Okay, so you can run the Spark on Yarn clusters, you can run it on the Mesos cluster, standalone scheduler, or it could be a Kubernetes. We no need to worry about these things, these four things we no need to worry about in Glue side, okay, because this is all managed by Glue. Just remember, in Glue we have workers, every worker has two executor. Now, what is executor? That is actually interesting, and that's why I have opened this PPT. So, whenever I submit a Spark program, okay, whenever I submit a Spark program, I submit it via Spark context. Now, what is Spark context? Spark context is nothing but you can say it's a detail about your job, like some context variable if we have seen in the AWS Lambda, same kind of context we also have in Spark. This context variables take some of the inputs, or it's like a metadata information that we pass to our cluster manager. Okay. Now in the actual Spark clusters, like where we have the managed clusters, like okay, as on the EMR systems or on Hadoop clusters like those, this cluster manager is responsible for two things. First of all, it is responsible to check in with worker nodes. Okay, so actually before knowing the cluster manager, let's understand about this architecture. So I have a main node, okay. Node here means a configuration of hardware and memory. If I say in very easy language, a node is a laptop. Okay, you can also consider as a node as a laptop. If I join 2 or 3 laptops by some mechanism, then that will become cluster. That means 3 laptops can work parallelly on same task. Obviously, that is going to enhance the processing speed of that task, and it's going to reduce the response time. Same way, we create clusters in real time. I mean, we guys developers do not create those, neither admin creates. It's like created by some other world companies, and we just rent out those or purchase those. Okay. So same way, a cluster is created, but in cluster, it's not a laptop. Actually, it's a hardware. It's just the hardware. That means it has some compute power, and it has some memory storage also. So if you remember, I had shown you worker type in yesterday's class, and that was saying 4 vCore CPUs and 16 GB of RAM. That is a worker type for you. That means that is your worker node. Okay, that is your node. Node means that is some hardware configuration that you will get. Now, these workers work parallelly on the same task. Okay, how it happens, let's say you submit a job using Spark context, and that is reading a file of 100 GB and doing some transformations, and then this cluster manager will receive that response. Okay, this cluster manager is actually not a physical thing, it is a software. This cluster manager will actually receive this thing, and it will divide that task into its worker nodes. Okay, in worker nodes, it's going to divide the task. These worker will launch executors. Okay, like it's a physical machine. Worker node is a physical machine. Okay, which is having some configuration. It is going to start a process. That process is called as an executor, and that executor divides that responsibility in multiple tasks, and it start processing those things. In the diagram above, or in the diagram that we have right now, we have two worker nodes. Okay, so basically it is just dividing the work into two worker nodes, and here you can say one more node is there, that is a main node. Okay, or you can say master node. So now these workers will work on the input and the code they have received. They will process that, and they will share the results back with the main node or your master node, and master node will return the result back to you. So when we see on the AWS Glue, let me just log in into Glue. if I just open any job, let's say this one only. If you see in job type, you can see the worker type. Okay, this is worker type, that is this worker. Okay, one worker, and I am saying launch one worker for me, and it should be a 4 vCore CPUs and 16 GB of RAM. Okay, and I am requesting how many numbers? I am just saying give me 4 workers. That is more than enough for me. Okay, so 4 workers will behind the scenes it's going to start 4 EC2 machines for me. That's why if you see when I click on job run and immediately I do not see the output. Like in Lambda, if I run the code in Lambda, as soon as I click that, like in 3 or 2 seconds, I get my complete output. But here at least 30 to 40 seconds are gone to launch the workers itself. Okay, so that is where the difference comes. This Spark codes or these codes are run on some actual physical workers. Okay, that means actual nodes are launched behind the scenes. Then this program starts executing. That's why it takes some time. Okay, that is what I was trying to explain to you. This the more number of workers, okay, the more number of parallelism we are going to launch here, the more power your that particular job will have, and the more faster it will execute. Okay, and this Spark context, if you see, if I open this job, you can see some boilerplate code I get. Okay, when I start my when I create my job, basically this code I get, and line number 9 you can actually ignore. I just imported this. You can actually remove this also for now. This much code I get by default. Okay, this much code I get by default. This means it is importing all the necessary libraries and all the necessary code to start a Spark context. And if you see here, I am passing a empty Spark context. Okay, I'm not doing anything here. Okay, and I'm starting a Spark context and Glue context. It is just that we are passing some metadata information about our job, programming language, worker type to the actual machines on the data centers behind the scenes. That's all we are doing here. Then after that, our actual code is getting started. Okay, so now I'll just take a pause here. And one more thing before I take the questions. If you don't get it completely, okay, if you don't get it completely, don't put any stress. This thing will take time. Okay, you can read some blogs, or you can come back to me a later stage of time. You can try to get it, read some notes, blogs, videos. If you don't get it, then you can come back to me, and this take time. And even if you don't get it completely, that is also fine. You no need to understand the Spark architecture on the Glue at least. Okay, till the time you are working on the cloud, be it Azure Synapse, be it AWS Glue, you no need to master this. If you know slightly, if you know basics, that is more than enough. So now yes, open for questions. No questions? I mean, you got it, or it's completely went over from you. Can you hear me, guys? Am I audible?
Yes, it is.
So you got it, or like it's completely
Can you
maybe?
hear me, Jalaj?
Yes, I can.
Yeah. My question is, like Redshift, when we are using the Redshift service, so we are renting out some server that would be permanent when we are using a Redshift. Now, in case of a Spark architecture,
Mhm.
we are when you showed me the setting and all, like worker node will be there, and this configuration the EC2 will launch. So now in this case, with the glue job, once we are run, EC2 instance will be generating on the fly, and once the execution will be done, the server will be also gone, right?
Yes.
Okay.
Okay, I mean, if you guys get it, it's good. If you don't get it, I'll share some link with you. Just go ahead and read that. Even if you don't get it, it's okay. At least on cloud, it's okay. Okay, and this is not a easy things to get in mind or understand without seeing the and practical or actual things. Okay, and unfortunately, I don't have a Spark a standalone cluster, so I cannot show it to you. But anyhow, moving ahead, okay, this is my job. This is my glue job. For this, I came like this. I go on AWS glue. I hit on ETL jobs and I choose Spark script editor and hit on create. Okay, when you hit on create, you get this code which I had highlighted earlier. This much code you will get it by default. Okay, no need to do anything here.
Chalas, I know it's coming for default, but could you please explain each line why we required everything step by step?
See this. Okay, I'll just wait. Okay, then if you okay, once you hit the create the job, okay, this will come automatically like this.
Right.
Now you can say, now you can say this is the important lines to set up your glue context and Spark context. Okay, so basically all the necessary libraries or all the necessary thing that we need to start this job, we will get it by default like this, such as from AWS Glue ETS, we will get resolved option. This helps you to get your environment variables and use those things in new code. Spark context helps you to create a entry point of your Spark job. Same way, glue context helps you to create an entry point of your glue and Spark job, and Spark session helps you create Spark data frames. Okay, without this Spark variable that I created on line number 13 using Spark session, we will not be able to create Spark data frames. Then using the glue context, I am just setting up or initializing my job. This code will be treated as a job. Okay, and then I'm initializing it with my job name. This job name, it is taken from here. This job name is taken from the arguments, like the arguments that I have for this job. I am taking the job name from those arguments.
Okay.
Basically importing my libraries, then just initializing my Spark context, glue context, and my job and data frame variable. That's all I'm doing here.
Usually the arguments will call like what we have to like. I mean, what could be the arguments like usually?
Argument can be your input file path, argument can be your output file path, argument can be your external libraries, argument can be some variables, any information it could be.
Okay. Mhm. So job name it will okay. We'll define the job name in job details, right?
Yes, in job details. So you have to actually, or we will need to change the job also. You cannot
Okay.
save the job with untitled job. Okay,
Oh,
and you also come down. Okay, and we set those things here in the library. We set the library. This I will show you.
okay.
Dependent jars. Right now I don't need it, and reference file path I also don't need it. I'm just going to show you the example of Python library path also.
Okay. Yeah.
Job
Yeah.
parameter I can just say here. Okay, if you want extra jars and all those things, like you want to mention those path, these are not going to install anything for you. Okay, some things will actually going to install, but it is like an example things.
Okay.
Okay, extra input file, the location you can share here.
Mm-hmm.
Okay, I need to remove this. I am just going to close this. And if you see in the job details for this job, I have used my same glue role. Like you can also create one glue role and use it again and again. Type is Spark. I think I don't have any option. Yeah, Spark streaming also there, but streaming we are not going to do here. We are going to do streaming on the Kinesis family. Then I have my glue version. Default is selected 3.0. You can definitely go on 4.0 also. Okay. Language I selected as Python 3, not as Scala. Then worker I explained, number of workers I explained, generate geometry insights. I don't actually want this. And then flex execution. I also don't want this. Then if I just slightly come down, yeah, rest everything is exactly same. Now one thing I'll just say, it is not a remind you again, actually again, it's not a completely free service. So in the initial stages, do not work with a huge data sets. Just take 40, 50 rows or 100 rows. Some KBs of data is actually good enough to practice. Like your syntaxes are going to be same for KBs of data also, for GBs of data also. So for practice, I will say use KBs of data and save some cost. Okay. If you run this job with like GBs of data, it's going to take much more time, and then obviously it's going to charge you more also. Okay.
Okay.
Visual Studio Code, so it can be visualized easily. Now, there are actually two things. Okay. If you see here, this line is also reading my file. Okay, this set of code is also reading my file. Then this set of code is also reading the file. Only difference is here, this is the glue native code. Okay, this is the code of AWS glue. It's neither a Python code or neither it's a code of Spark, and this code is going to give me output in the form of dynamic frame. This data source that I'm going to create, it's not going to be data frame, it's going to be a dynamic frame. And the difference between dynamic frame and Spark's data frame is, like, they have the same sort of use cases, but the dynamic frame is there with a kind of a dynamic schema. Its schema can change. It can be a schema less. It can have its schema can vary during the program. But the Spark's data frame schema,
Okay.
Spark data frame works with a strict schema. Okay, and then uh, the transformations that we can do on these two things are actually same. Like all the transformation that I can do on my dynamic frame, I can also do on the Spark, and say vice versa is also true, but the syntax is completely different. Okay, so if I go ahead and open the job which we created yesterday for our drag and drop purpose. Okay, if I just duplicate this and go on jobs, remember, this is the job that we created yesterday, the visual editor. If I open this, in the script, if I show you, it has same boilerplate code. Then it has glue context, create dynamic frame from options. Okay. Here I'm defining the same thing like format options, connection type, connection options, and all those things I'm defining here. Same thing with, but with some less options I have defined here. Okay, it's just reading the file and creating a dynamic frame. And then what I did, I just simply changed one of my uh, type. Okay, I changed my listing ID from string to big int. Okay, that's all I have done here. But if you see, the syntax is neither a Python syntax nor it's a PySpark syntax. Okay, so when we go ahead and work with dynamic frames, you are going to learn a programming language that is completely different, and it's only used on the AWS Glue. Okay, that is why I prefer to teach you the syntaxes. Those are native to PySpark. Those you can use anywhere in any of the project, and real times also when we code, like at least in the 3 or 4 projects that I have worked, I have not coded, like, or you can say projects does not prefer to code in this sort of syntaxes for obvious reasons. Just a second. Yeah, for obvious reasons, because whenever we hire someone from outside world, let's say you guys also, if we hire you, obviously you are not going to be learning these things from in the outside things. Okay, we hire the guys who knows Python, who knows PySpark. So we try to work on these syntaxes that is a generically and widely used. Okay, and that is also going to help you to create a resume where you can very confidently mention that you know PySpark and you have coded on the PySpark. That's why I'm also going to show you the PySpark syntaxes. We are not going to work with the Glue dynamic frame syntaxes. Is it clear? And obviously these are not easy to learn also. Okay, so if I just show you a filter in Glue dynamic frame, I don't know what I will get from here. Examples. I want example through dynamic frame. Here is the filter. You can see this is my no. This is my filter attribute. Okay, this is my filter attribute, which is trying to filter where state is in CA or LA, or state is in these cities. Okay, and I have to write a Python lambda here. Okay, but if I show you the same filter in PySpark, it's just very easy format. I just have to say this kind of filter I have to use. Okay, and if you know this syntax, you can work on Databricks, you can work on Azure Synapse, you can work on EMR clusters, you can work on AWS Glue. That's why I'm teaching you this one, the actual PySpark, not the dynamic frames. I hope it is clear. So now what we prefer in real time, at least for my project, we read in the form of dynamic frame and we write in the form of dynamic frame.
I have one question.
Yes, please.
This glue context is creating a dynamic framework, and this PySpark data frame would be there. So
Yes.
the schema is dynamic in Glue, and the schema is static in PySpark. This I'm not able to understand.
I'll show it to you.
Okay.
Okay, so actually what we do in real time, at least for my current project, we read in the form of dynamic frames because it's faster to read. And even if we can go ahead and read the empty locations, okay, that can also create a data frame. Or if you want, you can create the direct data frames. But what we guys do, we guys read in the form of dynamic frame. Then using on this data source, if you see, I'm just doing 2df. Okay, this 2df function is going to convert your dynamic frame into a proper data frame. That's what we do here. And if I just take out maybe what I can do here, I can comment out the rest of the code. I'm going to take it back to the cloud and not in this one here. Going to replace this, save it, and let's actually run it. See, dynamic schema means when you have this, when you read this thing, okay, and then you have a an integer column, and then you read one more file, and then the same column you have a string column in the other file. And when you try to do union or append or those things, it's going to work. And the best suitable format is going to be selected by the dynamic frame. That means its schema is flexible. But if you do same operations in the Spark data frame, they are going to fail with the error that schema mismatch is there. It is running. So to check the logs, I'm going to copy this ID. Okay, or you can simply click on the CloudWatch logs also. Just it succeeded. That's good. Output logs. So if see here, actually have you two ways to see the record. Okay, on the CloudWatch logs, you can display in the text format. So this right now it's a text format. Okay, like this, and you can actually go ahead and display in the form of columns also. I'm just going to hit the columns, and this is how you're going to get, and then you can expand it like this. So this is the data from the EMP-DF that I'm trying to read. Okay, basically just same file that we have used in the Python classes, and this is the output of this code. It is the output of this code, and I'm also printing the schema. That schema you can see here. Here is my schema from the file which I have read directly from the Spark data frame. This is directly I have read a Spark data frame, and here you can see index is integer, and it properly shows you data in a tabular data format. And to easy copy and visualization, you can just simply hit on this copy, open your notepad. ++ is a better option, and you can paste it like this. And this is your schema. Next, if I just scroll down, you can see this is the output of my dynamic frame. If I copy this, this is what I get in the dynamic frame. So basically, dynamic frame creates dictionaries for me, or you can say JSON format structure it creates and reads. And here, if you see, it's reading my rows into dictionaries, and you can see here it is not storing any schema information here. Okay, and I can do print schema on this also, and it's going to show you the schema. But next time, let's say I move this, like say this index is actually 29, it's reading in the string format only. But if I convert this into an integer, and if I try to compile those things, it's going to work. Dynamic frames are going to accept those changes. Okay, then I have converted back my dynamic frame. Here you can see I'm showing my dynamic frame output, data source 0. Same you can check here. Dynamic frame output is printed here. Then my dynamic frame is actually printed. Then I'm showing, then I'm converting it into a Spark data frame, and I'm showing it. So the next output is going to be from Spark data frame, which is obviously the same output as the top I got. So if I just copy this and get it on Notepad right after the normal EMPDF, you can see it's the same thing. So either you can read the data frame directly, or you can create a dynamic frame and then you can convert it. So it's an optional thing. Both options I have shown it to you. Nothing too good or too bad. Okay, you can use them as per your choices. There's nothing wrong or right here.
Okay. Jalaz, can you go to the Visual Studio? Yeah. So here, okay, you are showing in two different ways using the dynamic frame and Spark read dot. But in real time, so line 29 to 35 is not required, right? When we are using the dynamic frame.
Obviously, no. This is I'm just showing printing the messages.
Yeah, that's what it's making confusing. Like, so why we use the two ways? Like,
No.
So
Just
we
for
use
optional, just for the demo, I'm showing you this.
right. Yeah. Okay.
And see now we actually I was going to tell it a bit on later stage, but now if you have raised this question of printing this line, it is actually not advisable in production to
Right.
show a print schema. First of all,
Right.
due to
Because
security
that's not
reasons,
yeah.
okay, and second, this is Spark. Like if you understand the SQL, whenever you create a SQL, it generates a execution plan. Okay.
Mm-hmm.
Now, here in Spark, a DAG is generated, that is directed acyclic graph. How it is generated, it does not actually if I just uncomment my rest of the code. I don't know why it's coming like down like this. It shouldn't have. Okay, this shortcut that I'm using is control/. I think I have already told you, but it's a control/. You just have to select the code that you want to comment or uncomment and then press control/.
Right.
Okay. So let's say I have selected some of the columns, then I'm doing filter, and then I'm doing, let's say, joins and all those things. So Spark is not going to execute those lines. Okay, it's just going to say, okay, I have to filter the records where stock is greater than 3. Then I have to filter on M, and then I have to do some more filtering. Like that, it's going to keep all those things in memory. And when you do show or count, or you dump that data on some output, only on those cases it's going to actually execute these lines. Okay, before that it's just going to keep this in its memory that I have to do these things. Now if you do like this, that you read one line and you show, then you do one transformation, then you again show, then you do one more transformation, then you again show, then you do one more transformation or join, then you do count, and then you again do one transformation, then you again do show. So for all those 5 lines or 5 transformations, it's going to execute its code right then and there. But if you don't do show, all that much show, okay, and you simply execute your code, it can collect all those 5 transformations in memory at once, and it can generate a better execution plan, and it's obviously going to enhance the speed of your job. Okay, this is like juniors do make this mistake most of the time, and their jobs runs for 25-30 minutes just because they have 30 shows in a single code. We should only use show when it's actually needed. Just for printing the messages, we should not use it. Now, this Spark offers you 2 ways of coding. Okay, if you are coming from a very typical SQL background, okay, and it's something very new to you, you can still utilize the same SQL syntax on the PySpark. How we can do it? Okay, How we can do it? I can simply read. Let me just comment this code for now. Okay, it's going to create confusion in future runs. And this one is actually fine. So now right now I'm just reading my data source and I'm converting into two data frame. Okay. Then on top of this data frame, okay, you can ignore the show. On top of this data frame, I'm creating a temp view. Okay, you can say create temp view or create or replace temp view. Okay, this means now the same data frame which I have just printed here, this data frame, the second one. Okay, I can treat this data frame as a SQL table using the reference of sales data. Like whatever the name I'm giving inside my temp view, this temp view I can treat as a normal SQL table. And if I want to do any query on this table, I have to say SQL context dot SQL. This is my function. The SQL context dot SQL is my function, and I can create this function because I have already utilized my SQL context. Like I have first imported my SQL context from PySpark.sql. You can say you can understand or you can say it's a mandatory lines. Okay, but I have imported my SQL context from PySpark.sql, and then using the Spark context and this is Spark session, I have created the SQL context. Okay, now using the SQL context, I can write some SQL queries. So you can see I have created a table called as sales data. Then I'm using SQL context.sql. Then I'm doing a select statement. This statement which I have highlighted here is exact replica of your normal SQL that you run on MySQL, Oracle, or like that.
So
Okay?
Jalaj, we cannot able to do directly this create or replace temp view on data source data frame. Should we convert to dynamic frame to Spark data frame and then only we can use?
Yes, this is the functionality of Spark data frame.
So if you keep like a data source dot create or replace view sales data, so does it become any error?
Yes, it will give you error because this is see, understand, this is actually a very confusing. I know even like the developers who are working from 1.5 years with me in my team, they are still confused about this. They try to do the same mistakes. Okay, they do not understand the differences between Python data frame, Spark data frame, and Glue dynamic frame, because all these things look similar, but they are completely different. You can say the syntaxes at least are completely different. So this data source dot create or replace temp view will not work because this is not the functionality of Glue dynamic frame. Okay, this is Glue dynamic frame. This is Spark data frame, and this line you can execute anywhere where your Spark engines are running, be it as I always say, Azure, GCP, any cloud, anywhere. If you have Spark engines, this is going to work. This is not going to work. It's specific to Glue. This is going to work everywhere. Okay, and now you can see I'm just using cast operation as index, and I'm
Yeah,
selecting my
but
columns.
I mean, but we are working on glue only, right? So I mean, if you just go out of the glue and do some kind of commands, might be data source dot that create table replace. I mean, temp view won't work. But if we are working only on a glue tool environment, so why can't we use the data source dot create or replace temp view that function or
because
statement?
this is Glue's dynamic frame. This is the functionality of Spark.
Okay.
These are two different things. So basically, Glue is saying you can run Spark on AWS Glue, but I'm also providing you some of my own syntaxes, and its own syntaxes it is utilizing to create those visual drag and drop.
Okay.
Okay.
Jalaj, so okay, you created a temporary view, that's fine. But from the directly from line 39, Spark DF 40, from using the directly the Spark data frame, we can do all the transformations, right?
Yes, we
Any
can actually do it. So see, as I mentioned, for typical SQL guys who are new to these things, they might prefer this kind of syntax. Okay, but for the other ones, let's say you want to do some select statement only, and you want to do filter. Okay, you can do a filter like this. Okay, this is again, if you see my Spark data frame is highlighted, it's on the same data frame. I'm saying where spark.size is equals to m. I could have say stock less than 3. So it's the same operations I'm doing.
Okay. Any difference in execution or runtime performance?
PySpark syntaxes are preferred because they are less clumsy. What I mean to say, let's say
So if I do a group by basically certain column with Spark SQL, and if I do again a group by basically with PySpark
no,
like with the Python related.
no history, no runtime performance or differences are there. It's just a
Okay,
difference
no
from state.
performance. Okay, right.
I mean, it can be like you hit a 10-second here and you hit a 10.1 there. That is something that it could be there, and that could have various reasons. It might not only your syntaxes, it could be some other reasons also that like
Yeah.
it took some more time, but it won't be like that. This is taking 10 seconds and that is second 20 or 30 seconds.
Okay.
And obviously, if you make some silly mistakes, like you're doing cross joins or you are doing some some how do I explain this now? You are doing some stupid coding. That's what I could say now. Doing cross joins and running this code in loop. Like one of my junior, what he did, we needed to get the first day or last day of month, and what he did, he took the year and month, and he used to hard code the day as 01 for every month and year. Then he applied for loop to increase the day one by one unless he reached 30 or 31. When he reached 30, then he was checking which month it is. If it is January, then stop on 31. If it is February, then stop on 28. So if you do that kind of coding, I mean, nobody can help you. And
I
solution
have
for this.
one question.
Yes,
Yeah,
please,
sorry.
Prashant.
Yeah, I have one question. Suppose you are good in PySpark coding, and I prefer writing in dynamic frames. So, is there any scenario or use cases where it has to be written in one of the language, or it is just is the option is it depend upon the developer.
See, it depends on the developer, I will say.
Okay.
Anything that you can do on SQL, you can also do in PySpark, and anything that you can do on PySpark, you can do on SQL also. And yes, answer to that question is like whichever programming language it is, if you want to get the last day of any month, uh, either you have some functions over there, or you can have some better coding, but not a for loop to 1 to 30 or 31. Okay.
Okay. One more question I have. In You showed the content of this dynamic frame, and you were saying like we can modify the content also. Through the programming only we can modify the content.
Yes.
And with the dynamic frame, you gave an example like suppose name is suppose one column is there. One time it came as a string, and one time it came as an int. So in case of uh, Spark data frame, it will fill, but how come it will pass in dynamic frame? So this
Because that is a feature of dynamic frame. It is built like that.
so one column, if we are defining as a string, and one column defining the same
No,
column, we are
see what
defining
I'm
as a
saying.
int.
Wait.
So
What I'm saying, let's say right now I have a data source 0, and I create data source 1 also, and if I try to append those things, okay, do a union or append, then two different columns can be merged and I can have third data source created after merging those things, and it will merge even if they have a different columns. But if I try to do a union in Spark data frame and if they have a different column types, it will fail.
So suppose for the Spark data frame, if you wanted to see the print schema, so line number 33, we are doing the print schema. The same way, if I have to see the schema of the dynamic frame, then how I can see that?
It's the same function. If I'm not wrong, let's actually try it. Maybe this is my dynamic frame now. I'm going to just do it like. If it doesn't work, we will search on Google. Okay, so if you see what I was, let me just finish this now. I have used my SQL query here. Okay, and I'll give you more examples in tomorrow's class, like how to do read files, write files, and do some transformations. Today, we just wanted to start with some basics, and tomorrow we are going to do that on the notebook. So we'll also explain the notebook of Glue, and we'll also explain the PySpark syntaxes. So now, print schema, show, you have already seen, 2DF you have already seen, SQL context I have already explained. Same way I have filter, which is just doing filtering of my data frame. So this is like select star from table where size equals to m. Okay, and it's actually this like this is the actual command. And if I execute this thing and if I execute this thing, these two things are actually exactly same. And just in case when you want to get your Spark data frame converted into pandas, you can do it using two pandas. This is going to convert your Spark data frame into a pandas data frame. But remember, pandas data frame cannot utilize the full capabilities of a Spark function. So if you are working with big data applications, then you should always use Spark data frame. Those are optimized for the Spark engines for obvious reasons. Two pandas is a very rarest option. It is there. That's why I have shown it to you. Okay. So if I take this code now and execute it, if I don't get any error, and that means that print schema actually working. Otherwise, we will see how it goes. See, again, I'm repeating, don't memorize syntaxes. Don't memorize syntaxes. Let's say you want to do join in a Spark. You can say PySpark join examples. You will get it very easily. So I always say syntaxes are there on internet. Understand the concepts, understand the logic building, understand the pseudocode building. If you can write the pseudocode, you can write any code. Okay, so if you see here, join type and all those things they have explained, they have created some data frames, and now they will start applying inner joins and all those joins. We can see we have to create two data frames. Then we can say on EMP data frame, use join on department data frame, where EMP data frames, EMP department ID is equals to department data frames department ID. Join type is inner. Then I am doing a show. This is going to show me the output, and you can see this is the output. Same syntax, and now you just have to do full outer. It's exactly same thing, and then you have left and left outer. These two are same thing. Like rest syntax is actually same. Just join name you have to change here. Left means outer table will be treated as a left table. Inner table will be treated as a right table. Okay, and I hope you understand left join, right joins, and inner joins. Meanwhile, let's check the output here. I will just go on runs. It's actually succeeded. Yes. So print schema is actually working. Let's see what schema it prints.
Oh, Jalaj, the CloudWatch, instead of going the drop down, we can use the link, right? Whatever the
Yeah,
this
however it is feasible to you.
idea, using idea. Okay.
Yeah, however it is feasible to you. And if I'm
Both are
not wrong,
depends. Both.
if I just come down, yeah, this is my arguments, but I should have. Okay, I don't know why. Okay, it was such. Okay, this is actually maximum. Okay, I'm not getting anything here. Like previously, I used to get details here also.
Okay.
So you can see the schema of. Okay, these are my all outputs, and this is my schema from dynamic frame. Yes, that is the schema from dynamic frame. And if you see, it's treating index as a string only because it finds that index can be stored best in the format of string. And if I if I have that schema printed, okay, I don't have it here, but the Spark might treat that as an integer, not as a. Okay, Spark is also treating as a string only, but yeah, it's actually fine. This is Spark schema. This is dynamic frame schema on looking like it looks same, but you can there are some differences. Okay, it's actually more flexible, and the Spark one is actually quite less flexible. And if you see the output, this is from SQL query. Okay, this is from the SQL query, and this is from the Python data frame. Sorry, PySpark data frame. Both the outputs obviously are going to be same because we have used the same logic, just the syntaxes are different. And for more understanding what you can do, see, one thing I'm saying, whenever I teach or something, or whenever I explain something, you should definitely go ahead and take out 15 or 30 minutes of time and read some blogs and read or watch some videos. Okay, I'm going to cover these things and I'm going to explain you these things, but it is still a better option to go and learn more about those things. If you do it right now, it will be easy to grasp those things. If you do it later, then you might have to visit these recordings first and then you have to read other things. Okay, so what you can do, just search dynamic XMSU type versus, then you can get the data frame option, but just make it more clear. PySpark data frame, just do these kind of searches. Okay, so this is going to actually help you a bit. Let's just see what Stack Overflow says. And nowadays actually ChatGPT is also there, or you can try that also. You can see dynamic frame is safer when handling memory intensive job. Executed memory, the AWS dynamic frame never exceeds safe threshold. Okay, and this I had told you, like we prefer to read in dynamic frame because it's a bit faster than Spark read and write also. And then they say it's designed to provide maximum flexibility when dealing the messy data. That means if your data is lacking a declared schema, it is more flexible. Okay, for example, let's say schema changing and its column stored as a string in some record, and it might be stored as a struct in later records. So it's not going to fail your code, or it's going to it's going to merge, or it's going to take the best possible output for you. That's what I said. If you have an integer column and if you have a string column and then you try to merge those things, it's not going to fail your code. On the other hand, Spark is going to fail your code. And also, as I mentioned, we prefer reading using dynamic frame because it's faster option and it's more flexible. Even for writing, we use dynamic frame to write only. Like we convert our data frame into dynamic frame, then we write it over S3. So basically, what you can do now, you have this small job with you. You can try it out. This some syntaxes. Maybe I think I have it somewhere. Python shell job. Okay, meanwhile, if you have any questions, you can definitely ask me while I'm searching for the code of this.
Yeah, Jalal, last line, we haven't executed the write statement. Only we are read
Yes,
and
yes,
failed.
purposefully have commented that that is actually not the correct write statement.
Okay, in that case, we are using which format, like Parquet file or?
So you see, if I open it, AWS data
We are
engine.
taking CSV file, writing into the Parquet file, or using
Yeah,
different?
it should be Parquet file only. If I open this, let me just do it one thing. Don't say actually. This is I don't want to show you this right now. Spark SQL.py, it is the job that I have shown to you. Yes, it is commented here. And if I just come here, basically this is the code of the final project, and I'm looking. Yeah, it is this one. You can see we are going to code up quite a few things here. And Spark SQL. Control// and just select this Control-Shift-Tab. So
Jalal, what are the comment you are using? The command using for the uncheck comment.
come again, please.
What is the command you're using to uncheck the comment? Like control slash?
Control/.
Oh, okay.
To comment also and to uncomment also, it's the same thing.
Oh, okay.
Control power.
Control/.
Forward slash.
Control forward slash. Okay.
It is. I'll just type it also. It should be. Let's try this one. Data frame and dynamic frame. What happened to this? This is available. Oh, dynamic frame I have not included here.
Does this day 1, day 2 are getting shared by Ganesh, Jalich, this course?
Yes, you will get this code. Like this is the project, and I have divided this final code in 4 days.
Okay. Yeah.
So next week also we are going to continue on Glue.
We are going to, because this final code is actually connecting with DynamoDB. It is connecting with some other things also. So that's why.
Okay.
First, we are going to cover DynamoDB, Redshift, and Kinesis. Okay. Then we are going to come back to the final code. This is like project 2, and I have one more project that is going to be completely with Lambda functions.
Yeah.
So this S3 output path you can actually create. This path is actually going to be some location of S3. Okay. Now, how to get the location of S3? The simple thing is, let's say you want to save your files inside. If I open this S3, let's say for an example, you have this folder. Okay, you have this bucket, and you want to install store this file inside this particular folder. Okay, do what? Instead of copying and typing those things, you can just simply click on copy S3 URI. If you click on this, come here and paste it here like this. See, now this variable is not showing me any errors. This is how you can actually write. You have to say write dynamic frame from options. This is going to be same. You have to say the frame equals to dynamic frame. That's why I have converted my Spark data frame, the final one, whichever I have, and I want to save it and convert it into a output dynamic frame. This output I'm going to actually save. Connection type is obviously S3, and connection option is like art I have provided, and format is going to be Parquet, and then I have to provide a transformation context. That is, it is saying this one variable. That's all. And if I have,
Jalas, here we are giving file name. What is the file name we are giving? Data sync.
see, file name is actually a bit tricky here. You are not allowed to give any file names when you save the files in Parquet file formats. Under
Okay.
that folder, it's going to save the files.
Oh, okay. Okay. Got it.
So
Okay.
it will
In
be
that
a
folder,
kind of a,
the Parquet files will be saved. Okay. Got it.
yes. So it will be kind of a, a very random file names for you.
Got it. Got it. You're right. And sometimes snappy kind of files also will load. So
That
what does it
is
mean?
Snap. That is Snap is a compression type, like jar, archive. Those is a compression type.
Oh,
Snap is the
compression.
best suited compression type for the Parquets.
Oh, got it.
No, not inside this. Yeah. Training codes, not Kinesis. All this I'm actually going to show to you. It's glue, and then you need this one. Okay, so this is all from my end.